Hi, welcome to the Linux channel. So far I have discussed various topics or video episodes on OpenZFS or ZFS stack, and as well as I have discussed few topics on FreeNAS, FreeBSD, and as well as mounting or establishing a ZFS pool in Ubuntu server and things like that. So apart from that, I have also discussed about, as you can see, various topics on CodeWalk and stuff like that. Some are about research and some are like Q&A. So I do cover these episodes in case if you are in sysadmin or something like that. What happens is you being an infrastructure guy, you can get some insight about internals of ZFS. So based on that, you can plan and then you can fine tune your system and stuff like that. So this episode I would like to discuss about metadata, because often when you think about ZFS pool objects, so the actual data being stored, there's a lot of confusion may arise in terms of how much RAM should be required or needed. And apart from that, although you have a 10 gig NIC card, you may not getting sufficient amount of performance, or even if you have a 1 gig NIC card, it is not saturating the entire line speed. So if it is a 1 gig NIC card, you should get around 950 Mbps or something like that, provided the disks is also good enough. At the same time, it depends on your overall system processing capability, as well as in case if you have enabled compression and dedupe or any such settings, it depends on various factors, the overall performance you get. So that way, if you ask me, in my setup, I get around 80 megabytes per second on average, 75 to 80 megabytes per second. So there are few things I also think about. You can optimize your performance is also about how do you optimize your metadata. So in case if you are having NAS archives which are not compressed, sometimes you just don't have to compress. You can even at least do a tarball with some minimal compression. Okay, so it depends which level of compression you use. So in my case, if you see here, this is where the folder I have all this Linux channel video projects are stored. So I can quickly show these files the way I have organized. So you can see here, if I go any of these folders, it will be like this. So inside, let's suppose we take this folder ETH tool, and you can see here inside is the actual project it is stored. So some I may have that raw camera capture, some I convert that to some intermediate file, and then I maintain that as an archive. Okay, so that I don't have that raw footage from the camera. Again, it's a decision, it depends. Some people would like to keep that, some people may convert it into something. In my situation, I need to keep an intermediate stage, because the capture camera, whatever I capture here, is captured in mono mic. You can see this is a lavalier mic, so I capture it in a mono audio. So I have to do some pre-editing, and I have to convert that audio into stereo of this mono audio. So when you hear it, you will hear exactly whatever you hear in this ear, you are going to hear the same over here. So I'm just converting a mono audio into stereo. It's not a true stereo audio, so which is why I have to do certain steps, and then whatever I make from there, again I'm going to make the actual final render with all that overlays and other stuff. So finally the projects are kept over here. So this is what it is. So this way, what happens is, in a typical video project, I may have around 10 to 15 files or more than that. So it includes audio clipping, it includes any intro video sequence, it includes any screenshots, or even this screen record. As you can see here, these screen records. So if you see that way, the Linux channel have around 400 episodes. So some few episodes here and there are deleted, but if I keep collecting this, it is going to add lot of files eventually. So if I go back and then if I do some properties, it is going to show me how many items are there. So this is the actual crucial performance deciding factor, which many don't understand. It's just not the file size. It's all about the quantity of files and folders at which it is organized. Okay, your actual data is organized. So if you take, for example, a Linux source code, so if you take, for instance, a Linux source code, it may contain thousands of files. So let's go to some folder where we get some sample source code, the Linux channel. Inside we go to this folder, like yep, so somewhere like this. So if you do any properties, if you right click and click properties, it is going to contain millions of files. I mean, after it is compiled, it is going to contain even those compiled object files and binaries and stuff. So you can see here, it is nowhere going to end this. It is going to increase, and then it's just going to come down, and it is going to struggle like this. Okay, so it is beyond a certain threshold. So same thing happens if I do properties in my NAS as well. So if I do this, see, this is the actual mount. We have this mount. This is YouTube, the Linux channel TLC. In this, I have all these folders. In that grouped folders, again, there are some more groups. You can see here under this, I have some more folders. So this is how I have kept in this data set. Okay, so if you see that way, if I right click, sometimes it may show if it is small enough, and sometimes if I select all of this and if I do a right click, now it depends on the extent of that metadata is involved. So you can see here the items count is going to increase, and then again it is going to decrease, and it is going to retry the same. So it is never going to end. You will get some issue like this. So this happens the moment you have quantity of files is quite large. I mean to say not the file sizes, I mean to say the quantity of files. So each of this have to be maintained as a part of metadata, and metadata is also going to be replicated in the ZFS file system. So most of the times when you think about the ZFS file system, I may use both the nomenclature. When I call ZFS, I like sometimes to be called as ZFS, sometimes I like to be called as ZFS. So let's not bother about the same, because I too got some weird comments about my jargon, whatever. So I just want to call sometimes as ZFS, sometimes as ZFS. So the moment ZFS file system gets loaded into the RAM, it is going to load this metadata, and the RAM size, it's just not about how much these ZFS blocks or whatever it stores inside the RAM. It also going to have all that hierarchies and where one block is connected to other block and stuff like that. So all this is going to take up a lot of sizable amount of RAM, and this is the reason, of course, you must have heard that in a typical system, every TB of data ZFS pool, whatever you have, you should have around a GB of RAM and stuff like that. But provided it is just not about that, it also depends on how much is your complexity of your metadata. Okay, so that is something you have to not forget about. So which is why I thought, let me just cover this video so that it brings this to your attention, so you don't ignore this. So your performance also matters about how much is your metadata. For instance, if I try to copy this folder, the entire kernel source folder, which is not archived as a tarball or something, it is going to take more than an hour or something like that. Okay, effectively this folder should be around 200 MB or 300 MB more or less. Okay, so that way, if you see, it is not about the size of the folder. Typically, if it is a single tarball, it is going to take around maybe 5 to 10 seconds on average. If it is a compiled kernel source, then it may be around 400 MB or something like that. Okay, when you tar it. Okay, if it is a raw kernel source, it is going to be around 100 MB these days. Okay, around 5 years ago, it was around 60 MB or something. Okay, I'm saying about Linux 3.x versions. Okay, when it is 2.x, it is around 40 MB or something like that, the compressed tarball. Okay, so these days when you download a kernel source, the tarball is around 100 MB. So 100 MB, if I move from this system to the NAS, it is just going to take around 2 to 3 seconds. But the same 100 MB, if it is extracted, and it contains thousands of files, these thousands of files have to be, created in the RAM as well, as long as it is the machine is on. So it is going to add this metadata into that live instance. Okay, so when the moment ZFS is activated and it is live, it's going to be loaded in the RAM. So this particular metadata is going to be hot, which means it is going to exist in the RAM. Okay, so when such a scenario happens, your performance will go down, and the more files you keep without archiving them prior to moving to the NAS, it is going to add this overhead. So if you are a sysadmin, you can stress this point, or if you have full control, you can tar these files, you can tar entire shares. Again, it depends. When you tar them, you have some amount of overhead is involved. You need a decent processing device. Sometimes it is a data which you can manage, sometimes it is just some user created data or some team have created which you are not supposed to change. In that case, you need to just give them a NAS share so that they maintain them. But the problem is, the moment they don't archive and then put it in NAS, it is going to add always an overhead. Okay, so this is what. So in my case, I'm doing some work these days. I'm even I'm not posting that frequently videos. I'm doing some type of archiving, and I'm just getting my old videos in this format. You can see here, these ones are around 6.8 GB in this corner, versus this one is 5.6, this one is 5.5 GB, and so on. Some are 1 GB, some are 4 GB and stuff like that. So I'm just opening them, and then I'm re-archiving those old files. These are all very old episodes, so I'm re-archiving them. I'm deleting the camera source video files if it is sort of converted in an intermediate form. If it is containing some overlay stuff, I'm re-rendering it and recreating that. So that way I have done some of them. You can see here it has been kept in that folder as 2 NAS. So that is why I started this NAS. I'm going to put back these archived project files. So each of that, it is going to contain those things. So if you want, I can even show this particular episode project file. So if I open it, is going to contain around 5 to 10 files per folder. Some folders may contain more than that. Okay, you can see here, this is the tarball, and it is going to contain all this objects. You can see there are 17 objects is in this particular project. So that includes the actual file which I am supposed to upload it in YouTube. This is the one which is a first render of camera video files, which is with noise. It contains, of course, one side of audio is going to have noise, the other side is going to be fine. So stuff like that. So other than that, there are some trailers and other screenshots and banner and stuff. So this comprises the entire project which I'm maintain, and then this is what goes to YouTube, the final render. So the entire project comprises of so many video files as well as the other files. So if I don't tar it, of course I don't get any size reduction with a tarball, because there is nothing to compress. You can see here there are a lot of MP3 file and MOV files, and as well as MP4 files are all pre-compressed. So you cannot do anything with tar compression. But the main objective here is we have this bunch of files. We are clubbing all these 17 files into single file, and as well I have a script with that. I'm just making this MD5 so that in future, if I download this from the NAS, and if I see any corruption, I may predict that what could have went wrong with that MD5. I can get a hint that that particular data set or a pool may have an issue. So it is going to give some type of a hint. So I'm just keeping a count of these, and I have if I keep doing this, it may take around another couple of months of doing this work. So this is not something I have done earlier, but now I just started doing that, so which is why I was quite busy. Apart from that, I was also busy with some client stuff. So this is what, if you have a NAS system, don't evaluate the performance based on a single file copy or something like that. It finally boils down to what is the amount of metadata you have as a consequence of your type of data you have it in your NAS server. Okay, so that's what. There are certain places I can even show in the source code. See, currently I'm inside this FreeNAS stable source, FreeNAS 11 source code. Inside you have this ZFS stack, so I can even show you, but these days I am not much going through this. I'm not doing much of a code walk, and I'm still have to discover where it contains this particular files and other metadata. But if you generally explore, you can get some hints. See, this is where you can generally type about ZFS blocks, and you will get some kind of an architecturally representative pictures like this. See, this is coming from Sun Microsystem. This is a SlideShare slides. Okay, so they mention about how these blocks are maintained and how this copy and write and stuff like that happens. So this is all about a specific data blocks. Okay, so this means it's a block within the which is a part of that file, whatever. Okay, so we can see in that way they are kind of showing in a representation that how that overall concept happens. But you should also not forget that the more amount of files and folders you have, the more complex structure you have, the moment you do any copy or write to and fro from the NAS system, it is going to take a lot of time, and it is going to add a significant overhead. Okay, so this is what. So as a quick demo, I can show copying these files. All these files have to go inside GB/G4. So I can go inside that folder. It's a part of Toffee archive, and this is where all of this are supposed to go. So I have just have a small note on this whatever I'm doing. Earlier one file is around 1.8 GB. After compression it is around 3.18 or 17. The other one is 5.4 GB. After compression it is around 1.4 GB. The other one is 1.8 GB, and now it is around 407 MB. So this is what. So this is what all this 3 projects are supposed to go inside that folder GB/G4 Toffee. So I can do a cut and paste, and you can see it is a 1 gig Ethernet, and in that it is transferring currently at the rate of around 64 or 65 megabytes per second. So that translates around 650 to 700 megabits per second. Sometimes it can deliver up to 8 megabytes per second. So let's not take this quite serious. So it again depends on the disk type. All these are Western Digital 1 TB drives, whatever it contains, which corresponds to this pool. This is in big pool. This particular data set is in big pool. So each one drive it comprises is a 1 TB Western Digital desktop drives, except one is recently I changed it to Toshiba 2 TB drive. So it depends on that drive access, performance and stuff like that. So other than that, the major factor of getting you the performance, as I mentioned, is all about metadata. So once it is addressed, after that whatever the effective transfer rates you get is all about the disk performance and the memory, how much ever you have put inside your NAS server, and other than that is your network performance and stuff like that. So but you cannot ignore this metadata overhead. You will come to know the moment you transfer any large quantity of files, you will see some significant amount of performance bottlenecks. Okay, so in this case, since each one is a bulk file, it's just a question of 3 files and the other one is just a MD5. So it is just around 6 files and each one is around, combined it is around just, 2.1 GB. So it is not much. So it is just, it's a question of overhead due to, drive performance itself. It's nothing to do with, metadata much. But having said that, whenever you do such transfers, you should understand whatever the metadata it is existing, to that existing metadata it has to append these whatever new things are getting added inside that folder. So exactly, this is what is also going to be an overhead. The more once your NAS gets elaborate, the more shares you create, what happens is it has to maintain all this metadata, and that's where the moment you turn on the NAS, all this metadata is going to reside in the RAM besides your data blocks, whatever you generally find in anything in public domain like this. Okay, so which is why if you hop on to the NAS and check the amount of RAM, you can find its memory usage. It's going to be more or less, it is, in my situation, it is around 8 GB. It is going to, let us go to reports. It is going to consume around 80 to 90% close towards that, upper marks. And sometimes it is going to occupy some amount in the, swap space. So what I heard about the swap is, somewhere I read that the swap is not, typically going to be mounted in the hard drive, something like that, but I'm really not sure like how it can happen. Generally a swap memory is a virtual memory, it will be mounted in a hard drive, but I'm not sure. Somewhere I read, I need to yet confirm to the same. And more or less, other than this, I'm thinking to create a mirrored boot pool. I'm awaiting a new USB drive from Amazon. If I get tomorrow, I may shoot a new video adding a mirrored boot pool, because this is something you can do when you install FreeNAS, but I have not done that. I have installed in a single USB drive. I'm thinking to create a mirrored boot pool so that it can act as a redundant system. So once I get the drive, I may do the video shoot tomorrow so that we can all experience it in the live, so that as and when I do the changes, I can capture whatever the way you can create a dual boot pool. Okay, so if you go here, it is not going to show your boot pool, it is going to show all your data pools, whatever you created. So this is what but if you see here in disks, this is the USB boot drive, and this is the actual boot pool. Okay, so this is what, so you can find about it somewhere here. You can see here boot pool, you can find some information about it somewhere here. Okay, so that's what. So I'm going to do the same once I get the drive. But other than that, often I do get emails about the performance of ZFS and stuff. So what I can suggest is always have treat NAS more like a tape storage if possible. Okay, and keep archived backups in the NAS. Just not use it as any regular file system. Of course, you may have VMs and you can mount this VMs or put these VMs on a NAS. That's fine, but you are going to get an issue with respect to achieving any sizable performance without having that metadata bottlenecks. So it's not a big issue if you compare to a file system like this ext4 in this local system, because it works in a different way. If you think about any typical fat file system, it completely works in a different way, versus in ZFS it is completely different. You are going to have some amount of redundancy. It is due to that redundancy factor, it has to keep that account where these things are mirrored, where these things are spread across in those disks. Let it be RAID Z2 or whatever the configuration you have. In my situation, I have configured this as RAID Z2. So it depends, whatever the way you have created, it is going to spread this also across multiple disks. So whenever you do anything, it has to sync these things across the disks, and it has to do that for the data chunks as well as the metadata as well. So that's where the bottleneck comes. So, and on top, ZFS, as we know, it has the tendency to cache these things inside the RAM so that it can get quick access in terms of accessing these metadata first, and then serve that data objects as a file share, whatever. So this is what. So if you are stuck with any performance, try doing these tweaks. I hope you can address to an extent, but more than that, if you have some kind of a need or dependency, like I said, if you are using it for some VMs and stuff, then you need to work around and come with some kind of a strategy. Having said, even VMs, it will be kept as a single file. I mean, in my situation, I have this virtual box. It is all put as one VDI. You can see here. So it is going to exist as a one file, and then you have few metadata or whatever, that few supporting files. That is not going to be much, but this is what. So in that case, again, it is fine, but the more amount of files and folders and complex hierarchies put across inside a NAS share, it's going to add definitely significant overheads. And whenever you do rsync between this NAS server to some remote NAS server, even more you are going to hit upon this bottlenecks, because rsync, it has to literally do diffs between multiple files, and it's going to have its own overhead due to that. Okay, so that's what. So if you have anything else to discuss, be in touch via mail. Hope you enjoyed this video. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.